Imagine a wall of water 1,000 feet high, crashing through a narrow gap, refilling an entire sea in just a few centuries. This isn't a disaster movie. It's the real story of how the Strait of Gibraltar formed and changed our planet forever. 15 million years ago, the Mediterranean looked nothing like today. Africa was slowly grinding northward into Europe, driven by massive tectonic forces that continue reshaping our planet. This collision created the Atlas Mountains in Morocco and pushed up the seafloor, gradually closing the ancient connection between the Atlantic and Mediterranean. By 6 million years ago, something extraordinary happened. The Mediterranean became completely cut off from the Atlantic Ocean. Without the Atlantic's constant water supply, the Mediterranean began to evaporate under the scorching sun. Within just 1,000 years, sea levels dropped by over 3,000 feet. What remained wasn't a sea at all, but a series of hypersaline lakes scattered across a desert basin. Scientists call this the Messinian salinity crisis, and it created one of Earth's most alien landscapes. Salt deposits over a mile thick accumulated on the former seafloor. The climate became unbearably hot and dry. Marine life either fled to the Atlantic or went extinct. The Mediterranean had become a death valley, but tectonic forces never stop. Continued movement between Africa and Europe created fractures in the rocky barrier. Around 5.3 million years ago, Atlantic waters found their way through these cracks near present-day Gibraltar. What started as a trickle became a torrent. The refilling was catastrophic. Scientists estimate that Atlantic water poured through the breach at rates 1,000 times greater than the Amazon River. The roar would have been deafening. Within 100 years, possibly much less, the Mediterranean basin filled completely. This event, called the Zanclean Flood, ranks among Earth's most dramatic geological moments. The newly formed Strait of Gibraltar became one of Earth's most important waterways. Only 8 miles wide at its narrowest point, this passage now controls the exchange between two major water bodies. Warm, salty Mediterranean water flows out along the bottom, while cooler Atlantic water enters at the surface. This circulation affects global ocean currents and regional climates. Today, the strait continues evolving. Africa moves northward about 2 inches per year, slowly narrowing the passage. Geological evidence suggests similar closures happened before. In roughly 50 million years, Africa and Europe may collide completely, sealing the Mediterranean forever and creating a mountain range rivaling the Himalayas. The Strait of Gibraltar reminds us that even the most permanent-looking features of our planet are temporary. Earth's surface remains in constant motion, continually writing new chapters in our planet's incredible geological story.